we are now going to turn our attention to more interesting things, like models. They can help us understand what motivates trade and what the impact or effects of trade are likely to be. So we're going to start with the simplest model of trade that we can imagine. But I'm going to start actually with some quotes from a famous economist, Adam Smith. Adam Smith there's some passages from Adam Smith that are worth just knowing about and knowing that they were from Adam Smith, and it's going to relate to the model that we're going to build today. So I just want to work our way through a couple of passages. First one has to do with profit motive. You may have heard this before. It's not from the benevolence of the butcher, the brewer, the baker that we expect our dinner, but from their regard to their own interest. We address ourselves not to their humanity, but to their self-love, and never talk to them of our own necessities, but of their advantages. So the key to this passage, I think, is that it's emphasizing the role of self-interest. And that it is self-interest that's motivating individuals to participate in markets, to produce things. The butcher, the brewer, and the baker doesn't do what they do because their first thought is, what can I do for humanity? Their first thought is, what can I do that will allow me to put food on my table and serve my family well and to make myself and my household better off? They're first and foremost interested in their self-interest, not in what they can do for others. Now, what we're going to focus our attention on in the model we're going to create is, and as economic models tend to do, is we're going to assume that self-interest or profit or utility maximization is the goal of individual agents. But what we're going to show with this very simplest model of trade is that by serving your own self-interest under the constraints of the model, which we'll discuss in greater detail, what actually comes about is the betterment or improvement of the well-being of everybody that's participating in the system. And that is a somewhat surprising outcome. How is it that if you just do what's in your own interest, you actually serve others at the same time? Well, we're going to see how that can happen. Now, trade. We're going to talk about mutually voluntary exchange in this particular passage, and Adam Smith has a passage about that. He's indicating that it's a uniquely human endeavor or activity, trade, because he said nobody ever saw a dog make a fair and deliberate exchange of one bone for another with another dog. Animals do not do this, humans do this. Nobody ever saw one animal, by its gestures and natural cry, signify to another, this is mine, that's yours, I'm willing to give this for that. People do that. Because people do that, some very powerful effects are likely to take place, and we're going to look at those effects in just a few minutes. I won't read the rest of that. The last passage that affects us in some way here. The division of labor. He talks a little bit about how we break up activities in production into specialties, how we divide up labor into increasingly specialized tasks. And then we do our little thing in the corner somewhere and piece it together with a lot of other things that other people are doing in order to produce a greater abundance of productive capacity. We produce a lot more. And we're going to talk about that when we introduce the concept or theory of comparative advantage next week. But he says, this division of labor from which so many advantages are derived is not originally the effect of any human wisdom, which foresees and intends that general opulence to which it gives occasion. It is the necessary, though very slow and gradual consequence of a certain propensity in human nature which has in its view no such extensive utility. It is the propensity, he said, to truck, barter, and exchange one thing for another. What he's saying is that human beings have a proclivity to truck, that means move something to another location, barter, that means discuss how much of this will I give you for that, and then finally to exchange one thing for another. And it is through that natural propensity that some very amazing things can happen and can lead to the betterment of all people that are involved in this particular system. And we're going to focus our attention on how that can come about and why, and under what circumstances it will arise, and under what circumstances it might not arise in a particular simple market. And that's the purpose for building this model of pure exchange that we're going to start with today. All right, so we'll come back and we'll think a little bit about how these quotes affect what we're talking about. But let's move on quickly and assuredly to the model itself. A model is a simplification of the way in which the world works. We're going to make a lot of simplifications here so that we can focus our attention on just some of the key issues. Some of the simplifications are there just because we're trying to keep it simple and tell the story in a simple way. But some of the simplifications are there, some of the assumptions we're going to incorporate are there because we think this is a key characteristic about products, about consumption, about the utility or happiness we get from things, about the way things really work in the world. So I'll try to make a distinction between these as we go along. We're going to assume that there are two individuals. We're going to call them Smith and Jones. Now their names don't matter at all. It could be any two individuals. We can call them anything we want. So it's inconsequential that we're calling them Smith and Jones, but it's a whole lot easier to tell the story rather than saying person A and person B. So you've got two people, Smith and Jones. Smith and Jones have available to consume two goods, apples and oranges. We're going to use A to denote apples and O whenever we want to talk about oranges. The goods are homogeneous. We're not going to deal with problems associated with one orange being bigger and of better quality than another orange, which is smaller and of worse quality, because that complicates things unnecessarily. So remember, all the oranges are exactly identical to each other for the moment. Smith and Jones receive utility or happiness from consuming apples and oranges. We imagine that one of the sources of utility, happiness, though not the only one, is the consumption of goods and services. So if Smith and Jones consume apples and oranges, it's going to make them happy. Smith and Jones know what their preferences for apples and oranges are. They know how much utility they're going to get from every and any possible bundle of apples and oranges you may present to them. So that might be a strong assumption if we kind of think about our own lives. You know, let's say you're given, I don't know, double mint gum versus and a collection of sodas. You know, how much happiness are you going to? You go, I don't know, maybe like, I don't know whether I'm happy or not. Well, Smith and Jones know everything they need to know. Any two combinations of apples and oranges, 10 apples, 3 oranges, they know exactly how much utility or happiness they get from that. Compared to some other bundle, they know which is better, which is worse for them. They know their preferences perfectly. We're going to focus our attention on that in just a minute. Smith and Jones's preferences have two characteristics. These are very important and are true for the most part in most circumstances. First, more is better. If Smith has more apples than fewer apples, he's going to be happier because of that. So more is better. Now we can tell a story about how you may have so many apples, you're sick of eating apples and you don't want any more. In fact, you're tired of storing them somewhere. You could actually start to get lower utility by having more apples up to some high limit. But let's forget about those problems. Just imagine we're in the range where having more is better than having less. All right, so more is better. Second, diminishing marginal utility and consumption of both goods. Now, diminishing marginal utility means the change in utility that arises from a change in consumption. Let's say, and I like to tell the story this way, let's say there's a bowl of M&Ms on the table. I like chocolate, and so I grab a bite of M&Ms. Now, I take a few pieces of M&Ms, put them in my mouth and eat them. First bite of chocolate during the day. Let's say it gives me 10 utils of utility. Okay, I get 10 utils. 10, that's great. Okay, so I like it so much, the bowl is sitting there. Take another handful of M&Ms and eat that. Great, tastes good. But, you know, it doesn't taste quite as good as that first bite. So while it gives me more utility than before, maybe that second bite is only giving me 8 utils of utility. A little bit less. The marginal utility is 8. 2 bites, though, is giving me 18 units of utility. More is still better. So I take a third bite of chocolate. Okay, third handful. Now, still good, but now it's only going to give me maybe 6 units of utility. Okay, so as I take more and more, the additional utility gets smaller and smaller and smaller. That's diminishing marginal utility. Now, we might get to a point where I start taking my 8th bite and my 10th bite, and I'm starting to go, oh my gosh, you know, now I'm going to start putting on weight. I'm not happy about, you know, this is, you know, you start to feel bad, but you still kind of grab that bite. Now, an additional bite of chocolate is giving you like 0.3 units of utility. Still adding to your utility, but still not a whole lot. So that's diminishing marginal utility. And you can think about consumption of any item that you might like to or enjoy consuming And realize that everything you might consume is going to give you diminishing marginal utility eventually in the consumption of that particular good. At some point, you're just going to have too much of it, and too much of it is not a good thing. So, diminishing marginal utility is a feature of consumption, and we're going to incorporate it in our analysis. It's going to be important. Okay, we're going to imagine that Smith and Jones have an endowment. We're going to give them apples and oranges to start off with. And just to keep the story simple, we're going to give Smith 10 oranges, we're going to give Jones 10 apples, and we're going to see what happens with them from that point forward. One little tangency here. You know, I said I get 10 utils of happiness from the consumption of that chocolate, right? Why did I use utils as my measure? How do we measure happiness? Like, how do we, you know, we measure all sorts of things. We can measure the weights of things, we can measure the size of things, we can measure the brightness of things, we can measure, how do we measure the happiness that people get from the consumption of goods and services? Like the pure happiness, how is that measured? If you're lost, don't know what to answer, we don't have a way to measure that. We have proxies for it. We have things that maybe can be used to measure happiness a little bit, like, you know, like the gross domestic product, for example. We measure the total production of goods and services, the value in economic terms, how much it trades for in the marketplace. Why are we measuring that? Because it gives us some way of representing the happiness or utility that's accruing to individuals. But that's not a perfect measurement of the utility, and it's not a direct measurement of the utility we get. We'd like to, you know, it'd be nice if we had some kind of a wand or something. Could wave over somebody eating a bite of chocolate, and it'll register 10. Say, yeah, they're getting 10 units of happiness. I wave it over somebody else, it's an 8. You know, okay, you get more happiness than them from the same bite of chocolate. But we can't even do that. We can't measure the thing which actually turns out to be the most important critical thing that we're interested in trying to promote and achieve in economics, is to increase our well-being, and we can't even measure that directly. But that's just an aside. Don't have any answer to that, but it's just a matter of fact, so let's go forward. Now, we're going to assume that Smith and Jones are seeking higher utility first and foremost, and that sometimes we're going to imagine that they're actually trying to maximize their utility, to get the very maximum utility they can in the circumstances in which they face. All right. Maximization is not going to be completely critical because we're going to get good outcomes in this model even if they just improve their utility. They don't have to maximize it all the time. But we'll jump back and forth between those two assumptions. We're going to imagine that Smith and Jones are willing to engage in mutually voluntary trade. I'll talk a little bit about why that assumption is there later. And Smith and Jones know perfectly the quality of the other goods. So not only are all the goods homogeneous and identical, but Smith knows what Jones's apples are like, knows the quality, knows how much utility those apples are going to give to him, and vice versa. So knowledge is very important here, and we're going to relax that assumption in the story a little bit later and see how it can change some things. Now, some implicit assumptions we make. Smith and Jones can meet each other and talk about a trade. They can truck, barter with each other, and exchange the goods. It's physically possible for them to do that. And they can communicate with each other. You know, maybe they have to share the same language. These are important things that facilitate the trade of goods between two individuals in a particular market. If you can't talk to each other, you might have difficulty, or communicate in some way, you might have difficulty bartering appropriately and coming up with an appropriate exchange rate. Okay, how do we put this together into a model? We are going to create, first, a specification of indifference curves. Now, here is a grid. On this grid, we have oranges measured on the horizontal axis, and I'm measuring them in numbers of oranges. 2, 4, 6, 8, 10. I've got numbers of apples measured along the vertical axis, 2, 4, 6, 8, 10, and the in ones, 1, 2, and 3, and so forth. Every point on this grid represents a bundle that could conceivably be consumed of by Smith. So pick a point like here, right there where it says U equals 3, and we could identify that at that point Smith would be consuming 2 oranges and 2 apples, right? If he were at this point here, he would be consuming 6 oranges and 3 apples, right? Pretty straightforward. Now, we're going to imagine that Smith assigns a utility value, a happiness level, to every bundle of goods that can be presented on this particular grid. So I've made up some numbers here. These numbers are just made up. So u equals 3 might be the number he affixes to 2 and 2 here. He gives a number of u equals 5 there. Now notice, at this particular point, he has more apples and more oranges than he does at this particular point. So given the assumption that more is better, that had better have a higher number associated with it than the number associated here. Now, it doesn't really matter whether it's 3 and 5, or whether it's 100 and 500, or whatever. Just that the numbers are ranked so as to identify which is better and which is worse. Okay, that's why it doesn't matter if we can measure this. We just really need to be able to order these, to know I like this more than I like that. And we're imagining Smith can do that by putting a number, let's say, for simplicity, on any bundle that appears here. All right, next. Indifference curves are formed by taking those values that are on that grid of Smith and drawing a line through all of the points that give us exactly the same utility value. By doing that, we've created a set of indifference points, points along which Smith would be indifferent between consuming any point along the green line. So this line here, for example, passes through 2 and 2. We said that Smith got 2 units of utility at that particular point, so I've got u is equal to, 3 units of utility. Smith gets 3 units of utility at that particular point, and let's just imagine that these are all of the other corresponding points that give Smith 3 units of utility. So everything on the green line gives the same level of utility. Now, this line up here passes through this particular point, which was u equals 5. And so any point along this green line gives Smith the same 5 units of utility. If I said, Smith, do you want this point here or do you want this point over here? He'd go, I don't know, it doesn't matter to me, they're the same. But if I said, Smith, do you want this point here, let's say at that point there, or do you want fewer apples and more oranges at this point over here? Well, in comparing this point up here and this point down there, Smith can look at his indifference curve map and note that utility is higher up here than it is down there. So he would rather have this point because it's on a higher indifference curve, giving him higher utility. And in general, we can see that as we move upward and to the right, giving us more apples and more oranges, we must be jumping onto higher and higher and higher indifference curves. That is, higher utility values for the indifference curves. So utility is increasing for Smith in this upward and right direction. Now, the last thing that matters here is that these indifference curves are curved. They're bowed inward towards the origin. They're curved in. And that inward curvature comes about entirely because of the assumption of diminishing marginal utility. So indifference curves look the way they do because of those two assumptions. Let me give you a quick example. If we started at a point right here with Smith having 1 orange and 8 apples, and we said, how much is 1 more orange worth to Smith? Now, first thing we'd have to ask is, how do we measure 1 more orange? How do we value that orange? Well, one thing we could value it is in terms of the other good that he might be willing to give up in exchange. So if we said to him, how much is 1 orange worth to you, starting at this particular point, Smith might say, well, I'm willing to give up about 2 apples in order to exchange 1 orange. And that would give me about the same level of utility, right? So 1 orange is equal to 2 apples. Or we might say the second orange to Smith is valued at 2 apples. But what about the third orange to Smith? The third orange is jumping from this point to the right, and in getting the third orange, Smith would only be willing to give up 1 1/4 apples or so in order to get back to the same indifference curve. So in other words, the second orange is worth 2 apples. The third orange is worth less, 1 1/4 apples. The fourth orange is going to be worth even less. That's the concept of diminishing marginal utility, measured in a kind of an odd way in terms of the other good. But we're going to get that relationship because of the curvature, the bowed inward nature of the indifference curve. Now, suppose the indifference curves were straight lines, just straight. then there's a constant relationship that would constantly be given up. That would mean we have constant marginal utility. So straight indifference curves would be constant marginal utility, and if they bowed in the other direction, outward, then we would have increasing marginal utility, which doesn't really make a lot of sense, and I can't even think of a good which would give me more and more and more happiness each additional unit that I consume. Maybe some addictive drug or something like that. All right, so indifference curves look like this because of the assumptions we've made. You with me? Next step. We've got another person. The other person's name is Jones. Jones can consume apples and oranges too. That's the only goods in our simple economy here. And Jones too will have a set of indifference curves that looks much like Smith's. Now they might be bowed a little bit differently. They might be steeper for Jones or flatter for Jones than Smith's, but they're all going to be bowed inward and increasing as we move to the upper right for Jones. The trick for Jones, though, and in order to create our diagram that we're going to work with in this model, we're going to flip Jones around and make him do everything upside down. So here's Smith's indifference curves, a different set than the ones I drew over there. And I'm not actually giving numbers to them now. I'm just calling them I1, I2, and I3. We know, just by looking at this graph, that if we're on the outer red line, we've got higher utility for Smith than on inner red lines. We should know that moving upward and to the right gives Smith higher utility. Jones is over here, and he's got indifference curves too, but we're going to put Jones does everything upside down, so he puts his origin up here like this. And he increases oranges in this direction, 1, 2, 3, 4, 5, 6 to 10. He increases apples in this direction, moving downward. So he does everything upside down relative to Smith. Now, you can just kind of turn this around, and it looks exactly like Smith's indifference curves, or we can just keep track of it upside down like this, which is what we're going to do. So Jones has a set of indifference curves, but for Jones, increasing utility is in this direction, down and to the left, right? Because that's giving Jones more apples and oranges. You should be able to take a diagram like this, and I could pick a point, like, say, right here, and you can tell me how many apples and oranges would Jones be consuming at that particular point. What's the answer?
5 apples, 7 oranges, and
Okay, 5 apples and 7 oranges. Okay, easy, right? All right, now here's what we're going to do next. Now we're going to give Smith 10 oranges. We're going to say that's what he's endowed with. Somehow, magically, they arrived at his doorstep at the beginning of the day. Walks out his door, didn't have to produce anything, didn't have to do anything, just opened up his door, there's 10 oranges sitting in front of him. Homogeneous oranges, they're all exactly alike. Jones is going to be given 10 apples. Magically endowed with them. He just comes upon them, he just has them in his possession, no work was involved, they just magically appeared at the beginning of the day. So now, if we wanted to say, how much utility does Smith get with 10 oranges and 0 apples, we would look at his indifference curve map, go over here to the corner. This is the point of 10 oranges and 0 apples. Smith would get the utility associated with this indifference curve, I2. All right, I don't know what the number is. Maybe it's 5, 10. Doesn't matter. It's just some value of utility. Okay, if Jones is given 10 apples, then his endowment is going to be at this point on his particular graph, right? Because apples are measured in this way. 10 apples here, 0 oranges. Jones would get whatever utility is associated with I2 indifference curve, the blue one for Jones. Okay. But now, here comes the next part. We're going to create what's called an Edgeworth box. What we do with an Edgeworth box is we take the endowments of our individuals and we place them on top of each other after having made one person go upside down, like Jones. Okay, so notice that his endowment is over here, EJ. Smith's is over here, ES. So what we're going to do is we're going to plop them on top of each other. I don't like the way that looks. And we create a box. Now, this particular box has dimensions given by the total amount of apples and total oranges that are available in this simple economy, right? The length of the box is 10 oranges. The height of the box is 10 apples. We've got their endowments placed on top of each other. And this is the starting point for the trade story that we're going to tell. But before I tell that trade story, I want to highlight the fact, maybe, possibly, conceivably, I'm going to highlight the fact that the endowment doesn't have to be 10-10. That Edgeworth boxes can be created of different dimensions, and it depends on the starting point that we raise. All right, so let's suppose that Smith was not given 10 oranges, but was given 1 orange and 6 apples. That would make Smith's endowment point right here, and would actually give him exactly the same utility as he would have gotten with 10 oranges, because he's on the same indifference curve, right? Okay, but let's give Jones a different endowment. Let's say Jones was given 7 oranges and 2 apples instead. That's what his endowment. So he opened up his door. There was a combination of apples and oranges at his doorstep that day. Okay, well, if this is Smith's endowment and that's Jones's, then to create the Edgeworth box, we're going to superimpose somehow, if I can get it, superimpose those endowment points on top of each other. Yeah, that's right. And it's going to look something like that. Now the Edgeworth box is this box right here, which has dimensions, it looks like 8 and 8. Because the total amount of apples and total amount of oranges in the economy, given the endowment we started with, is 8. So that gives us a box of different dimensions and gives us a different starting point for the analysis that we're going to do. But the analysis we do from this point would always be similar. It's just going to look a little bit different. Okay? Okay, so straightforward, I think. Now, we need to talk a little bit about what happens next. So here's a couple of diagrams. The messy one on top is got all the indifference curves drawn for the 2 individuals. The ones that matter the most to us, though, are the ones that pass through the endowment points that they start at. The ones that pass through E down here in the corner. And so I've got a bunch of other dots plotted here, but I'm going to eliminate all that mess by going to this particular diagram, which just has the indifference curves that pass through E. Those are going to be the ones that will give us give us our bearings, if you will. Now, the thing that's immediately obvious from this particular diagram is, well, that it creates this eyeball-looking thing, this eye, right? And this eye I'm going to call a lens, because it kind of looks like a lens. And we're going to note that it might be possible for them to move into this particular lens, but the only way to move into the lens is for them to trade. They have to exchange apples for oranges. And if they exchange apples for oranges, they could trade to any point on this diagram. Because any point on this diagram is a possible combination of goods if they're only willing to kind of give you something in exchange for something else. All right, so first of all, let's imagine that we move from point E to point D. What would be the trade that would have to take place to get to point D?
They each trade.
1 apple for 1 orange. Very simple. Jones gives up 1 apple. Smith gives up 1 orange. They trade it between the 2. And then they trade it. How many apples and oranges does Smith end up with at D?
9 oranges and 1 apple.
Okay, 9 oranges and 1 apple. How many apples and oranges does Jones end up with?
9 apples and 1 orange.
9 apples and 1 orange. Okay, so they're just trading 1 apple for 1 orange. Now, if they did that, and we'll come back and we're going to define some economic terms in just a second, but if they did that, what's going to happen to Smith's utility, his happiness, after trading?
It's high.
It's got to go up, right? And it's got to go up because point D, although I don't have an indifference curve drawn there, I know that that point has to be above the indifference curve that's drawn in red, and so that's got to put him on a higher indifference curve. So that's going to give him a higher level of utility. Smith is going to be happier because of consuming 9 oranges and 1 apple than if he had to consume all 10 oranges. What about Jones? What's his situation moving to point D? Better or worse?
Better.
He's better too because his indifference curves are increasing to the lower left, He gets to a higher indifference curve as well. So here we now see kind of the magic of trade. By trading, both Smith and Jones are getting a higher level of utility, are making themselves better off than they would be if they didn't trade at all. Hang on to that thought. We need to define some terminology now. And largely we do this just so that I have questions to ask you on a quiz. Just kidding. We define something called the terms of trade. TOT for short. Terms of trade is a trading ratio. It is what Smith and Jones are going to barter over. They're going to have to make a decision. How many apples will you give me? How many oranges will I give you? What is the trading ratio that we're going to come up with? If we put them as a ratio, and we put the number of apples traded for the number of oranges traded, we have created the terms of trade between Smith and Jones. Now, we could write the terms of trade in two different directions, of course, because we could form the ratio with apples on top and oranges on the bottom, or we could do it with oranges on top and apples on the bottom. It doesn't really matter. We can write the terms of trade either direction, but of course the numbers would be different for a particular trade. Now, for the sake of the future argument we're going to make, it is also very worthwhile to recognize that the terms of trade can also be written in a more kind of digestible form, an easier way to understand. And that is by looking at the ratio of the prices of the goods themselves. So the terms of trade written as apples per orange, listed here, is actually the ratio of the price of oranges divided by the price of apples, where the price of oranges in a normal market that we're all used to is denominated in dollars per orange. Go into the market, and a lot of times it'll be priced. Oranges are $1. Okay, so the price of oranges is $1 per orange. That's the usual way we think about prices. The price of apples, some other number. It might be 50 cents per apple. It might be $2.75 per apple. The price of apples in dollar terms is written below. If we take the ratio, we're taking the ratio of units, which are dollars per orange divided by dollars per apple. And if we simplify those ratios of units, dollars per orange times apples per dollar, because we take the denominator, switch it around, multiply it by the top, the dollars are going to cancel out, and we're going to be left with units of numbers of apples per orange. So the ratio of dollar prices of two goods in a real market are actually giving us the terms of trade, how much of one good trades for how much of another. And so that's another way to represent the terms of trade. Now, if I wanted to write it as the other ratio of prices, PA over PO, that's going to simplify to the number of oranges over the number of apples. Now, we could say or call this terms of trade or use the following terminology. We could call this terms of trade below the price of apples. But it's not the price of apples in terms of dollars when we write this ratio. No, terms of trade is the price of apples in terms of how many oranges you get in exchange at the marketplace. So we're denominating prices with a terms of trade not in dollar units, but in units of how much of the other good trades for it. And that by itself can make this a little bit confusing. But let's go back to our diagram. And let's ask really quickly, what's the terms of trade in moving from point E to point D? We did that before. What would be the value of the terms of trade? 1. Put the units in. Would it be 1 apple per orange or 1 orange per apple? It's both. Okay, they're the same. What if we moved and traded from point E to point C? What would be the terms of trade in apples per orange? Traded to point C, right here. The terms of trade is going to be 3 over 7. Right? Because in order to get from E to C, Smith is going to have to give up 1, 2, 3, 4, 5, 6, 7 oranges. and he's going to have to receive 1, 2, 3 apples. So the exchange is 3 apples trade for 7 oranges. That's the terms of trade in moving from E to C. If they trade to C, how many apples and oranges does Smith have?
Yeah.
3 apples and 3 oranges. How many apples and oranges does Jones have at point C? 7 apples, 7 oranges. So those are 2 questions I can ask you about this diagram, and will. Okay, so find a point that they trade to. How much are they consuming at that point? To that, you've got to look at their origins, and you've got to count from the origins to the individual point to identify what the bundle of goods is for each individual. You did it in the first graph, it's easy. Do it in the second graph, it's still the same exercise. Second question I'll ask you is, given we have an endowment point, something they come to the market with, if they trade and move to another point on the diagram, what is the terms of trade? To do that, you've got to start with whatever the endowment is. Here it's at point E, and you've got to count over and up to get to the point that you're moving to. Let's suppose they moved to point J instead. They traded from point E, the endowment, to J. What would be the terms of trade? Write it down on your piece of paper. Test yourself. What would be the terms of trade going from E to J? And then when they got to J, what would be the bundle of goods that Smith and Jones would each be consuming? Write it down. E is down here in the corner. J is up there. What is the terms of trade, and what is the consumption bundles once they arrive at point J? Answer. Following. Terms of trade is going to be Smith has to give up how many oranges to get to J? Answer 1, 2, starting from E. How many apples does Jones have to give up to get to J? 1, 2, 3, 4, 5, 6. So it's going to be 6 apples for 2 oranges. 6 over 2 simplifies to 3 apples per orange. So the terms of trade is 3 apples per orange, and moving to point J. Once they get to J, Smith is consuming 8 oranges and 6 apples. Jones is consuming 2 oranges and 4 apples. I can just read it off the graph. Total number of apples and oranges, still 10. You just mixed them up between the 2 a little bit differently. Okay, now, yeah.
Could you do the reverse of that and instead of 6 over 3 or 6 over 2?
You could do 2 over 6, and then you would have oranges per apple. Yeah. Take note of the question. I might ask you, what is the terms of trade in terms of apples per orange, or something like that. Then I want it in that particular direction. Okay. Now, go back to our original exercise, moving from E to D. E to D raises the welfare utility of both Smith and Jones if they were to trade to point D. But you might ask why. What's the intuition there? And here's the quick intuition for why trading into the lens is going to make both of them better off. It doesn't completely rely on this, but it has a lot to do with diminishing marginal utility. Because the story with moving from E to D, why they're both better off, goes something like this. I'm Smith. I eat oranges. Day after day after day. Every day I wake up, I've got 10 oranges at my doorstep. I eat oranges. That's all I'm consuming, day after day. Each day I eat the first orange, I'm hungry. I eat the second orange because I'm still hungry. I eat the third orange, I eat the fourth orange, I eat the fifth orange. As you all know, in consuming, if you were to eat 10 oranges during the day, that 10th orange, while it might provide some nutrition, it's not going to be as pleasing as the first orange in the morning. All right, so Smith has the possibility with trade with Jones now to give up his 10th orange, which is not that valuable, in exchange for a whole new product that he hasn't consumed ever before, an apple. And if you could give up your 10th orange to create and to get your first apple of the day, I think we could all, in our own experience, recognize why that might make you better off. Okay, well, Jones is exactly the same way, but he's got too many apples. His 10th apple is what he's giving up, Jones, right? That 10th apple is not worth very much to him, but his first orange is worth a lot more to him. So, both Smith and Jones can rearrange the goods that they have in their possession in such a way that they can actually both walk away happier because of trade than if they didn't trade at all. Now, keep in mind, How do we measure happiness in an economy before? Remember we said we measure it like by measuring GDP, right? We measure the sum total of goods and services produced in the economy. That gives us our level of utility. Well, let's look at the simple economy. Smith & Jones come to the market with 10 apples and 10 oranges. If we measured the value of GDP in the market, we would come up with some number. The oranges are priced at this. We've got 10 of them. So let's say oranges are $1 per orange. Total utility is $10. Apples are $10 as well, $1 per apple. $20 is GDP because we've got 10 apples and 10 oranges. Now, what happens when they trade apples for oranges? What happens to the total value of these goods and services in the economy? Nothing. But what happens to happiness in the economy? It goes up. So that gives us an indication that GDP is not capturing all of the well-being that's being created in the economy. Well-being is being created after the fact. After all the GDP has been produced and we have its value, GDP welfare is being created when exchange takes place between people. Because exchange comes about when somebody comes to a market and says, I have too much of something, I'm going to give this up in exchange for something I have too little of. Now, normally that exchange is not going to be apples for oranges. Normally it's going to be, I'm going to take the money out of my wallet, I'm going to use my credit card, and I'm going to use that to buy the thing that I don't have in my possession right now. And for me now, buying something, the cup of coffee that I buy in the morning is worth more to me than the $2.50 in my wallet. So I'm going to make that exchange because it makes me better off. But you know what? At the Starbucks, they have too much coffee. They would much rather have money instead of the coffee because they can't consume all of the coffee and be happy with that. They want money. So they're willing to give up the coffee, which they have way too much of, in exchange for money, which at the moment they have way too little of. While you, walking into the Starbucks, are willing to give up the money, which you have too much of, in exchange for the coffee, which for the moment you have too little of. And both Starbucks and you will be happier as a result of that exchange that takes place in the marketplace. So every time you see two people come together in a market, whether a real market, a farmer's market, a supermarket, a virtual market at Amazon, every time an exchange takes place, mutually, voluntarily, willingly, it's taking place and generating an improvement in utility for both sides of the exchange, of the transaction. Both sides are walking away happier as a result. I like to call them happiness bursts because it's like these bursts of happiness that come out of nowhere. The surplus that's being created just because people are exchanging one thing for another. And it's happening every moment, right as we speak. Bursts are taking place all around this city, all around the country, all around the world. Right? Bursts are taking place because people are exchanging one good for another. All right, next. D is not the best they could do. If they were to trade to D, they would be on an indifference curve that looks like this, and they might say to themselves, hey, wait a minute. We just traded to D, but look, if we could draw our indifference curves like economists do, then we would look at our graph here and we'd see there's still a lens that's being created. We could trade even more and make ourselves even better off. Right? So how could we determine what is the best place we could trade to? That's something economists would like to know. And that's something we might realize if we assume that Smith & Jones are trying to maximize their utility. Because if they know everything they need to know, and they can communicate with each other and barter for a long period of time, they're not going to stop at D. They're going to say 1 for 1 makes us better off, sure, but we can do better than that. So how can we do even better? Now, there's a couple of concepts in economics I want to raise your attention to. Pareto optimums. What is a Pareto optimum? A Pareto optimum is a point on this diagram whereupon there is no additional trade that would make Smith & Jones better off. And that Pareto optimums arise wherever the indifference curves of the two individuals are touching or tangent to each other. So what I have here is a bunch of Smith & Jones's indifference curves that are just touching each other at one particular point. Now you'll notice that if they touch at a particular point like this, then there's no way for them to trade up or down in either direction without possibly both of them, having a reduction in their utility. There's no way to trade to their mutual benefit. As opposed to, say, this point over here. At this point over here, there's a lens being created by their two indifference curves at that particular point. They could trade up in this direction and make themselves better off. Once we get to the green line, which is the line of Pareto optimum points, the tangencies, there's no ability for them to trade to their mutual advantage anymore. They're stuck, if you will. And that's the way that they could achieve the maximum gains from trade for the two of them. All right, so that's one condition. If they're going to use their full knowledge and maximize their utility, our next stop is to say, well, then they should end up at a Pareto optimal point somewhere along the green line. But here's the problem. Where on the green line will they end up? If we go back up here, you might note that if they traded to the green line, and let's say the green line, they traded to this point over here, well, that's a very different outcome for Smith and Jones than if they traded to a point, say, up here on the green line. I don't have the green line drawn here, of course, but I'm just imagining it's where my arrow is. Okay, because if we move to this point on the green line, then Smith is like, oh yeah, that's really good. I've gotten a big boost in my utility. But Jones is like, yeah, it's better for me, but just a little bit of an increase in utility for me. The surplus is being distributed unequally. Smith is getting a bunch of it at a point like this. Jones is getting just a little bit of it. Similarly and oppositely, if we traded to a point like this. So we might ask, well, how would they decide where along the green line they would trade to? Well, there's another complicated way in which economists have said, well, we could write this as a mathematical equation. We can do the optimization exercise. We could find out what would have to be true for them to maximize their utility and find a unique point on the Pareto optimum lines. What would it look like? It would look like this. Turns out that to maximize your utility, they would have to satisfy the following condition. Now, don't worry too much about this. I want you to be aware of it, but I don't want you to fret about it and to spend lots of time studying this and forgetting about everything else. I just want to show that, like, flash this to you. Have it in your awareness set. Okay? Now, the left-hand side is the terms of trade, right? We defined that, and that's simple. It's just it's actually the slope of the line between the endowment point and the point to which they trade. So if you would look at this particular point S, one thing that would be true is that the terms of trade would be the slope, which is this distance, the number of apples, divided by the number of oranges moving over to the endowment point over here at E. So the slope of that black line is the terms of trade. That's the expression on the left. Now this right side is scary looking, and MU stands for marginal utility, O stands for oranges, and this upper part says the marginal utility of oranges for Smith at a particular point, let's say. MUA is the marginal utility of apples. How much more utility would you get from an additional unit of apples consumed? And the ratio is called the marginal rate of substitution. But in terms of the diagram, this marginal rate of substitution on the right-hand side corresponds to the slope of the indifference curve at a particular consumption point, S. Now, the slope of the indifference curve happens to be exactly equal to the terms of trade at this particular point, S. Therefore, this condition, which we've determined mathematically, you don't have to do this, but would be determined mathematically to have to be true if you're maximizing utility, would be satisfied. All right, so all we're doing here, all that's important for you, is to note that if we imagine Smith and Jones maximize their utility, then they would achieve that maximum by satisfying this condition, and the equilibrium would look something like this. Namely, it would be on a Pareto optimum point and the green line, defined as we've defined Pareto optimums, and it would be at a point where the terms of trade line passing to the endowment is just tangent to the two indifference curves at that same point. If you can have those all conditions satisfied at the same time, we have discovered or determined a unique point to which Smith and Jones can trade to. And they would simultaneously be maximizing their utility or happiness. Wonderful outcome, wonderful condition, unique solution, if we make some additional assumptions, like maximization of utility. Okay, but there's a couple of other concerns we've got here. I'm going to go past this really quickly because I don't want to spend too much time with you worrying about this particular diagram. So I want to talk a little bit about some other assumptions that are embedded in this particular model now. Some assumptions that are not often talked about, but ought to be talked about in a little bit more detail. So let's say they trade to a point like S, and I've said they're both maximizing their utility if they were to achieve that particular point. But here's what's a little bit funny about that suggestion. If we look at point S and say, well, for Smith, if that's his maximum utility point, how does point S compare to, say, point O for Smith? Is S better for Smith than point O if we could achieve point O? Which is better for Smith?
Oh my god.
O gives him more apples and more oranges. So clearly, Smith has not maximized his utility under all circumstances because he's picked a circumstance that's worse than getting to O. But the problem with O is that he might not be able to get Jones to agree to O. Okay, so we've got to get them to agree to things simultaneous. Now, is S the best of the 3 points listed here? Which is the best point for Jones? P, S, or O? P is going to be best for Jones. So if we were to say Jones were maximizing his utility given the Pareto optimal points drawn, then P would be the best for Jones, while O would be the best for Smith. But wait a minute, it doesn't stop right there. If we were to ask what was the overall ultimate best position for Smith to be in on this entire 10 by 10 diagram, where would that be? Go back up to this diagram to give us a... Which is the very best point that's labeled on that graph for Smith? Not H. K is the very best point on the graph for Smith. The best that Smith could do, really, is to have all the apples and all the oranges. Who cares about Jones? If Smith is truly self-interested and only cares about himself and his family, then he would best be served if he could somehow figure out a way to get to point K. While Jones, on the other hand, also being self-interested, greedy, trying to do anything for himself and doesn't really care about Smith at all, would want to achieve which point? A. All right, now there is an alternative way for Smith and Jones to achieve those particular points. But to achieve them, we have to jump outside the assumptions of the model. So in particular, let's think about how Smith might be able to achieve point K. He arrives at the market with Jones. Jones pulls out his 10 apples, Smith pulls out his 10 oranges, and they begin a discussion. Whereupon Smith pulls out a big club, hits Jones over the head, walks away with the 10 apples. End of story. Solution. Solved. But we didn't let that happen because in the model itself, we actually make an assumption that Smith and Jones come and make a mutually voluntary trade with each other. And by making that assumption, we are ruling out the fact that Smith could hit Jones over the head and take all of his apples. We're also presuming that, well, we're not allowing that action. And by not allowing that action, we're actually incorporating some important principles into this particular structure, into this model. So for example, if Smith and Jones are truly going to engage in mutually voluntary trade, then to be mutually voluntary, you've got to be able to come to the market, offer a terms of trade, and if the other person refuses, you say, okay, I guess I'll offer a different terms of trade maybe. But you're not allowed to hit them over the head, or you're not allowed to threaten to hit them over the head if they don't accept the terms of trade that you just said. Or you're not allowed to sneak away with the apples when Jones runs off to the bathroom for a minute. Right? You can't do any of those things, and by not doing any of those things, we are presuming that Smith respects property. Respects the property of Jones, and respects the fact that when Jones comes to the market, those apples are deemed at first to be the property of Jones, and that it's not acceptable for Smith to take, steal, or threaten to take, with violence, try to force or coerce Jones into giving the apples to him, will not take it surreptitiously, steal, that he respects the property rights that Jones has in those particular apples. And so Jones is free, under our assumptions, to give up the apples or not give up the apples. But if he chooses not to give up the apples and go home, then he can go home safely. He's not going to get mugged on his way home. He's not going to have the apples taken away from him. All of those other outcomes are really, really important, that we recognize that we're ruling them out. And by ruling them out, we are incorporating a system of property rights into our model. Property rights are an important component that must be adhered to in order to prevent K or A from being the outcomes. So there's a system of ethics, if you will, that's incorporated in the model that's very important in order to guarantee that we get the win-win situation that we described by Smith and Jones trading to some interior point like E or H on this particular diagram. We incorporate a presumption that property rights are prevailing, and that in turn means that we're agreeing that Smith and Jones not steal from each other. So kind of inherently imagining that there's an ethical principle not to take from the other and to engage in trade instead. Now there's one other aspect, and I'll raise, and then we'll talk about these points in a little bit more detail next time in class. But the other aspect is an issue related to perfect information. I made a point earlier of saying that the goods were homogeneous, that they were all alike, and that each individual knew exactly what the other person was giving them and knew what the quality was and how it was going to affect their own utility. So if I'm Smith and I trade with Jones and I get apples, the apples are exactly what I expected them to be. They were of exactly the right quality. They all were the same. Everything was what I expected. But what if that's not true? What if the apples that Jones are giving up some of them are good, but some of them are not so good? What if he gives a sample apple to Smith and says, here, try this one. You'll see it's really, really sweet. It's great. Tries the apple and says, okay, good. I'll take 5 of those. And then Jones manages to fit into the bag 5 really, really rotten apples along with 1 good one. And then Smith gets home at the end of it and goes, oh my gosh, these are terrible apples. I had no idea what I was getting. We make the assumption, in other words, of perfect information and that the knowledge about the goods is there because we want to rule out the possibility that you're going to end up receiving goods that were not expected, that were not what quality or what circumstances or that you expected them to be. And if we ask, does this happen in the real world, we would know that the answer is sometimes yes. That a lot of times we do enter into an exchange for goods and services, and we come out on the other end of it going, oh my gosh, I was just screwed. You know, I got something I didn't expect. I ordered something from Amazon, it came from them, and it wasn't what I expected. They won't take it back. Now I'm stuck with it. We've got situations like that where we eliminate the assumption of perfect information, and by doing that, it opens up the possibility for deceptive practices to take place in exchanges. And this is one of the reasons why there have been many times when we may have made a mutually voluntary exchange because we expected the product to be of a particular type or quality. And when we go back and consume the product in the end, we discover we're not so happy about the outcome. You know, a good example would be, I go to see a movie. I've seen the reviews. It looks like it's going to be a good movie. I'll pay my $12 or whatever ridiculous price it is to go see the movie at night. I watch the movie and I go, oh God, it's a terrible movie. Now that I know it's a terrible movie, I would never have spent $12 to go see it, but I didn't know it beforehand. So I ended up engaging in a trade where I got something that was of less value to me than the money I gave up. So trades do sometimes occur which are not win-win. But in that case, it's not deception so much, it's just misinformation that didn't allow me to know the quality of the good and how much value it would really give to me ahead of time. And we've got mechanisms that we use to try to address those particular situations. So next time, we're going to talk a little bit more about these ethical principles that are embedded in this model, and we're going to talk about the mechanisms that are used to help maintain